All right, so just like in the warm-up, there's an easy way to determine the end behavior of a polynomial, which, by the way, the end behavior on either side is always going to be one of what two possibilities? Infinity or negative infinity. That's it. There's no horizontal asymptote. They go on forever, either up or down. So remember that a sub n, in general, for an nth degree polynomial is what we were calling the what? It's the coefficient of the x with the largest degree, so that would be your leading coefficient, okay? If you simply just look at the sign of the leading coefficient, if it's positive, that is greater than 0, then the limit as x goes to infinity is positive infinity. So if the leading coefficient is positive, then the right end behavior, the reb, is positive. And conversely, if the leading coefficient is less than 0, negative, then the right end behavior is negative. Okay, so if the leading coefficient is negative, then the right end behavior, reb, is negative. So you don't actually have to even worry about like plugging in a representative type of positive infinity into the x. Just look at the sign of leading coefficient. But you got to remember, it always gives you which end behavior? The right end behavior. Okay? Now, once you know that, then you can look at the degree to figure out the other end behavior. In the event that maybe you don't even have an equation, that's what we're working towards, just kind of thinking abstractly. So if your degree is an even number, not necessarily y-axis symmetry, but if your degree is like 2, 4, 6, or 8, then what do you know about the end behaviors? Same or opposite? Same. Then the end behaviors are the same. So if you have a positive leading coefficient, you know the both end behaviors are going to be positive. And if you have a negative leading coefficient, you know both end behaviors are negative. And you can always kind of refer back to your old friend x squared to help you with that, right? X squared is an even degree polynomial, and positive x squared opens up, and negative x squared opens down on both sides. But if you have an odd degree polynomial, then if the right end behavior is positive, then the left end behavior is negative. And if the right end behavior is negative, then the left end behavior is positive. In other words, the limit as x goes to negative infinity and positive infinity are the opposites of each other. Okay, they come in one side and go out the other side. Okay, got it? Let's try example 4 then, very quickly. It says determine the end behaviors of the following polynomials. Now I do want you to always practice proper notation. So to analyze the end behaviors, we're going to write the limit as x goes to infinity of f of x in this case, and the limit as x goes to negative infinity. Okay, so I'm looking at my leading coefficient. It's negative 2. So negative infinity for sure is going to be the what? Left or right end behavior? The right end behavior, yeah. So it's negative infinity. Now if you look at the degree, which is 4, that's an even number. So the end behavior should be what? Same or opposite? Same. So it should be negative infinity on the other side. And it is. Okay, the other way to do it, if you're lucky enough to have the equation, which we are here, you can just plug in a representative type of infinity. So if we're going to the right, positive infinity to the 4th is positive infinity times negative 2 gives you a negative number. And if you plugged in a negative infinity, what's the negative number to the 4th? Positive times negative 2 gives you a negative. But again, we are working towards not having actual equations, just having information or characteristics about a function. Okay, cool. Letter B. I'm going to go ahead and write it out. The limit as x goes to infinity of big P of x. And the limit as x goes to negative infinity of big P of x. What's the degree of this polynomial? 4. So the leading term is negative 2x to the 4th, and the leading coefficient is negative 2. So negative 2 is a negative number, so that gives me the right end behavior as being negative infinity. And the right end behavior is always x going to positive infinity. Now, because, again, it's an even degree polynomial, the end behavior should be the same. So the left end behavior is also negative infinity. So this graph comes in from the bottom, dances around locally, and exits the bottom. That's what we're saying. So just like negative x squared, you have a negative 2x to the even power. It opens down, essentially. But it has a lot more interesting local behavior than x squared, as you'll see. Okay, letter C, g of t. So we're going to take the limit now as t goes to infinity of g. So I'm kind of switching the variables on you on purpose. Our independent variables t, our dependent variables g of t. and the limit as t goes to negative infinity of g of t. All right, what's the degree of this polynomial? 7. Good. The leading coefficient then is what type of 2? Positive. So that should give us the which end behavior? The right end behavior. So that should be positive infinity. And as you look at the degree then, you'll notice the degree for the first time here is an odd number. And so the end behaviors are opposite. Odd, opposite. They both have the ah sound, right? Maybe that'll help you remember, if you forget. In this case, you could actually just plug in and get the representative sign. Now, if I add a couple more terms to that one, I get letter D. The limit as t goes to infinity of big N of t, and the limit as t goes to infinity, negative infinity, of big N of t. What's the degree of this polynomial? 7, right? We have the exact same leading term as we did before. We just have a bunch of other terms behind it. The terms that are behind the leading term affect the graph locally, not at the ends of the graph, but locally. So the more terms you have, the more interesting things you're going to see locally, like relative max or mins. It's going to wiggle more. It's going to be curvier. You're going to have more x-intercepts. You're going to have more y-intercepts. But for the end behavior, it's going to behave just like the previous one, right? It's a positive leading coefficient, so the right end behavior is positive. It's an odd degree, so it's opposite end behavior, negative infinity. Okay, so the leading terms sign always gives you which end behavior? Left or right? Right end behavior. Good. And then looking at the degree, you can decide if it's the same or the opposite on the left-hand side.